Hi, I'm Aubree Jolly, and this is a special episode of the Perce Soil and Water Conservation District podcast. December 5th is World Soil Day. It gives us a chance to celebrate the importance of healthy soil. This international recognition of World Soil Day encourages the sustainable management of this amazing natural resource, soil. Today, I've met with Brian Gardner from the USDA Natural Resources Conservation Service to learn about the unique qualities and complexities of the Nez Perce County soils. Why don't you introduce yourself?
Okay, well, I'm Brian Gardner. I'm a soil scientist with the Natural Resources Conservation Service. I work in the Soil Survey Division, so we're kind of responsible for soil inventory and soil data for the United States, basically. The agency has that responsibility. And I work out of the Moscow MLRA Soil Survey Office, and I'm the office leader here. So I get to be involved with soils every day. Hooray! So Lynn asked me last year, I guess, for kind of a set of soils that would be kind of unique to Nez Perce County or somehow important for the county anyway. And I came up with this list of cul-de-sac, Hatwai, and chard as kind of three that stuck out to me as being interesting and kind of, if not unique to the county, at least maybe the county's the best example in the state of the soil or something like that. So like, for instance, cul-de-sac, if you know anything about soil taxonomy, we have a pretty elaborate system for assigning a class to soils that is hopefully a little bit carries some information with it, right? So if somebody hears the scientific name, they know a few things about the soil. So cul-de-sac is an ashy overloamy, mixed, superactive, frigid, alphic vitracerand. All of that kind of means it's an andesol, so a soil with volcanic ash, in this case on the surface. It's got XER in the name, which means it's in a xeric climate regime, which around here we have a lot of influence from the Pacific Ocean, right? So we get most of our precipitation in the winter coming from the ocean, and in the summer we get under high pressure and it gets hot and dry. So wet winter, dry summer. That's the idea behind xeric. So this is an andesol, soil with the volcanic ash in this xeric environment. North Idaho in general has got a lot of these andesols. Volcanic ash influenced soils are pretty widespread, especially in the mountains, right? As you come down out of the mountains, the ash influence decreases. Our theory is that it's got to do with when the ash was emplaced. The vegetation helped preserve it basically in forested areas. As you come down slope and out to the west, things dry out. Grasslands, ash is very light, fluffy material, so grasslands don't protect it very well. As it gets deposited, the wind can pick it up and keep it moving. So once it's deposited under trees, it's protected better. And that's where the thicker ash caps occur. The ash around here is, I think right now we're saying it's about 7,000 years old. It's from the explosion of Mount Mazama, which is a mountain in Oregon that is now it's Crater Lake. But before it was a big volcano, and then it blew up kind of like Mount St. Helens and made this big ash deposit over here. And it was larger than St. Helens to some degree because, in this area, the Mount St. Helens deposit might have got up to an inch thick, something like that. Okay. The Mazama stuff you can find now is 14 inches and more, maybe up to 20 up in the mountains again. So yeah, a lot of ash material. It wasn't all in place at once. The model that we've got in our minds about it now is similar to Mount St. Helens. The plume would have gone up from the mountain and then kind of come down like around Ritzville or out in the central basin there. That's where the first big impact would have been. But again, it's out there in that dry area and not very well protected by vegetation. So over the course of time, wind picks it up, re-entrains it, and blows it on to the east. So over a century or so after the initial deposition, it kind of gets all moved up into the mountains, and now we have it over here in much thicker deposits. And it's pretty important stuff for forestry. It's being light and fluffy. It's got a lot of water holding capacity. So again, with our dry summers, it helps forests kind of survive and prosper in areas that are drier than they normally would. I guess the soil has this ability to store water in an available form, not hold it too tightly, and the trees can use that, and so they're able to survive at lower elevations and drier conditions than they would without it. And so foresters are always really interested. Where is the volcanic ash? So that's I brought that up to Lynn because it is something that kind of people are always interested. The second one on the list is this Hatwai series. I was looking on the maps at it today. There's a little bit of it on the Lewiston grade, but most of it is kind of up east of the orchards. There's crop fields and stuff over there. I don't know if that's Tammany or not, but most of it seems to be mapped over in there. And it's kind of interesting because it's a natrazerol. It's a mollisol. It's got a thick, dark surface, but it's got a horizon that's rich in sodium, which is a feature of dry conditions, that sodium persists, because sodium's highly soluble, right? So it doesn't persist in the soil if the rainfall is very high. I've never seen natrazerols anywhere but over there. Clay materials in the soil will generally tend to flocculate, so they'll kind of cling together into kind of structural units, clods, if you will. Even, when you dig it out, they'll kind of tend to break into things we call structure in soil. And sodium works against that because of the way it binds to the exchange sites on the clays. And they don't stick together. They'll kind of get dispersed. And so there will be kind of a lack of structure in the high sodium zones. And so that makes them very hard for water to penetrate. It can lead to a lot of problems with management, basically, right? And then they will have a kind of a characteristic look, a real high sodium profile. You'll see there might be some large kind of columns, they call it, and then the top will be this white material because the water can't get through. It kind of leaches out really the tops of those columns where it can't penetrate. So you'll have this real white material. The overlying maybe molic horizon is dark, and then this really white zone, and then the high clay, pretty impenetrable underlying stuff where all the sodium is. And it is very characteristic and kind of neat to look at. Right. Right? A very picturesque soil when you see it. If you can find one of the old documents for the Lewis and Nez Perce County Soil Survey, they've got some pictures in there, black and white pictures, unfortunately. But they do have a picture of Hatwai in there because it is pretty photogenic. Right. People like to look at that too. And then the last one on my list was chard, which is another xerol. So xeric environment, mollisol, has the dark surface, probably developed mostly in grassland. That's usually how you get a mollisol. And it's kind of interesting because it's developed in alluvium, kind of coarse textured alluvium, but lots of fine sands, basically. And so it's, of course, down along the Snake and Clearwater rivers. This is one that's more widespread, actually further to the west, out into Washington, but we get it in the Lewiston Basin there, and that's probably the biggest concentration of it in Idaho is right there. And it's, my understanding of it anyway, is that most of the material is related to the Missoula floods. You've heard about those? So it's kind of off here at the distal end of the flood where it's like kind of the finer sands got pushed up this way. We don't have a lot of the big rock fragments and coarse sands and stuff like that you might find out closer to the center of the floodway, right? We got some of it pushed back up, even like back up the Clearwater. It would flow backwards up the Clearwater because the water was deep enough, right? Push back up that way and deposit this kind of fine sand material. As you go up the Clearwater, other series are mapped on it because its climate changes. It starts to get wetter as you go farther to the east, but around Lewiston, it's the right climate and the right kind of material and everything to be called chard, if it's the concept. Because when we're mapping soils, basically it's nature is highly variable, right? So you've got certain materials and certain climates, but they all kind of blend into each other in a continuous fashion. And then we've got these soil concepts. To put a name on something, you have to kind of describe a little box of soil properties and say, okay, if it checks all these boxes, it's this soil. And then you draw a line around it to make the maps, right? But all those boundaries are really pretty fuzzy. We always talk about the soil concept, the thing that we would call chard, a few things that are perfect, and then there's a whole bunch of other associated things that are pretty close. And if you're mapping chard in an area, you might go ahead and include the stuff that's not quite perfect. Keep it in there because it's, chard is the closest thing, rather than set up a unique series for every little variation that you come across. So we do a lot of that and trying to decide, is this different enough to be something different or does it fit the concept well enough? We're always kind of worried about interpretations for use, right? People are going to try and use this for home sites or for agriculture or something like that. We just want to make sure that everything that's been put in the same box kind of interprets the same way, even if it doesn't fit the described concept perfectly. So that's what I spend a lot of my time on.
That seems like a really interesting thing that you focus on as a whole in your profession, but really on the day-to-day or on the year-to-year, I guess, like what really does a soil scientist actually work on? I know you said you try to, categorize things, but I'm sure there's more to it than that. So is there any kind of information you can give on what that profession really looks like?
Yeah, so just as a description of day-to-day activities, I guess. It's interesting now because the project I'm working on now is a little different than anything I've ever done before. So there's like the classic soil survey is to go out in a county, like Nez Perce County, and you're looking at a landscape, and you know you're going to have to break it up on slope groups for one thing, and geologic groups for another thing. So you can do a certain amount of pre-mapping, where you've already kind of divided the landscape on things you can detect from the office, right? And then you go out and start digging holes and to see what the underlying soil materials are like. Because we're working off this idea that there's basically these 5 soil forming factors, parent material, time, biological community, and so forth. And where one of those changes, we expect, the soil's going to change too in response to that. And so we just have to figure out in this county what are the combinations of soil forming factors that are important, and what are the soils that you find in a particular set, And so you do all this digging, and you can get the texture, and you can get the colors, and you kind of classify it, and you'll accumulate a set of classifications in like one particular landscape segment that you're interested in. Like, I'm on this basalt ridgetop. It's broad and relatively low slope, and maybe it's got some loess on top as well. And I dig around and I find, most of it's these argizerols, right? They've got an argillic horizon, a molic epipedon, and maybe they're fine. They have more than 18% clay. And after I get enough of them, I'll decide, that there's this series concept that fits that's been used around here, that I'll use that name. And you can develop a map unit of, say, something like, I don't know what would be in in Tammany or something like that, but like the Palouse series. It's Palouse in a certain slope group, Palouse 2 to 10% slope. And then you can actually draw that on a map. In the old days, all our mapping was done on aerial photographs. That's how we navigated around. Now with GIS, we do a lot more drawing on the computer screen, And so it would, day by day, you would just cover the landscape doing that, digging holes and putting things into a set of boxes that you kind of have worked out ahead of time. You kind of know what soils you're going to be dealing with in your county, just from experience, after the first couple of years. The thing I'm working on now is different because we're working down in central Idaho on the Payette National Forest. So it's a large area. There was only 3 of us, and we want to get it done in like 3 years. So the old-fashioned system I'm talking about, before, you might have 3 to 5 people working on, and a county could take you 10 years, and that would be like maybe 1 million acres. And now we're working on something that's like 10 million acres, and have a much shorter time frame. So we're getting into this computer modeling approach to doing mapping. And so you kind of do pre-mapping again. You stack up all these layers of landscape variables in the computer, and then ask it, where can I go that kind of covers all the variability the best? And it tells you, go dig here, go dig here, go dig here. And we constrain it by, it's got to be near roads, it's got to be something I can get to, and like things like that. And then we just go out and collect the information, and then come back, decide how we're going to model it, right? Are we going to use series names? Probably not. It's a little too precise. So I've started looking at trying to model soil features, like the ash cap. How is the ash cap distributed in this area? The subsoil textures, are they loamy, are they loamy skeletal, are they sandy? 3 kind of simple classes. Like that, we had basically 4 properties we ended up trying to model, and then kind of stack them all up and say, this is the soil in that spot, this kind of set of 4 properties. And then we go out at the end and collect a bunch of data and see how well the model reflects reality, basically, right? So it's like it's not great, but it's given the constraints of manpower and time and so forth, that it may be the best we can do for now. The good thing about it is that more data will always improve the model. So if there's ever somebody has time, as long as we don't lose our old data, they can keep adding to it and make things better and better, hopefully. Project for the future, I guess. The day-to-day stuff is people don't realize often that most of the day-to-day mapping is based on things you can observe in the field immediately. There's not a lot of taking samples back to the lab or anything like that. What's been done in the past is, as you accumulate observations, right, you get an idea of what's the most common kind of soil in your area, and then you can go back and do a more detailed lab sampling of something like that. Like we've done that once on the Payette. We took 1 week and sampled like 6 sites, that represented things we'd been seeing a lot of, and hopefully next year we'll get to go back and do that on the remaining area, where we haven't done sampling yet. But another 6 sites or so that represent the most commonly observed kind of soils. Soil scientists usually are kind of people who can work by themselves comfortably, yeah, and maybe don't do a lot of talking to people on a day-to-day basis. One of the things I think that's interesting, and people maybe know this about the Perce, right? The Perce is kind of unique in that it's all built up out of these loess deposits accumulating over time. So loess is wind-blown material, right? Okay. So it's basically kind of silt-sized material because that's what's most easily transported by the wind for a long distance, right? And the Perce is related to the outburst floods, the Missoula floods, because the material that forms the Perce is what the floods carried down. They came out of the mountains, up around Sandpoint, Coeur d'Alene, Spokane, flowed across the plateau southwest from Spokane, cut across the plateau. Some of it followed the Columbia, some just went straight overland. And you get to, I think it's near Walla Walla, the Horse Heaven Hills, come together at a place called Wallula Gap, where the Columbia cuts through. And it's a narrow spot, right? So all that floodwater hits the narrow spot, backs up, and makes a temporary lake. And so a lot of the sediment it's carrying gets deposited there. So that's why if you go around Walla Walla, there's something called the Tushy beds. Mm-hmm. There are these layers of material that represent the floodwaters dropping their load of sediment at that point, and then they slowly drain away, right? And then you've got all this material that's been dropped and dries out, and that's what the wind picks up and blows back this way and builds the Perce Hills. And so this region is kind of unique because of that, right? And I think there's the only other place of this extensive of a loess deposit is over in China, and they've got a similar thing in Asia, but this is comparable to that. And so around here you've got volcanic explosions depositing materials in the mountains. You've got gigantic floods, kind of reshaping the landscape out in the central basin, and then placing material that gets blown back over here in big loess deposits. I've always thought there was a big debate in early geology between the catastrophists and the uniformitarianism or something like that. The idea was, well, is the landscape we see formed by these giant disasters that happen, or is it like the slow work of processes we see at work right now, just accumulating over time? And, the debate, basically the uniformitarians won. It's like, yeah, most of the stuff we see can be explained by processes we see at work right now, working over a long period of time. And that's generally true. But you come here, it's like, well, there are catastrophes. Catastrophic events do occur, and they do shape the landscape to some extent. There's room for both. Right. And this place was a good wake-up call that, yeah, that's true. Those things do happen.
How does understanding more about our soils benefit us as a society, or why is it important that we learn about our soil properties?
I guess the main thrust of like what NRCS is concerned about has always been interpretation for use. Mm-hmm. And so soils, because of their characteristics, can be, more or less suitable for uses. I think it probably got started in the earliest days just with ag productivity was the major concern, and what crops are best adapted, can these soils support certain kinds of crops. That's partially why climate is so wrapped up in classification for us, because that certainly affects what plants can possibly grow. And I know that back in the Midwest, in particular, they paid quite a bit of attention to how soils are rated for productivity for corn and soybeans and stuff like that. Because there are some variations depending on drainage and things like that. Mm-hmm. As time's gone on, the set of interpretations that we present has gotten bigger, right? So now there's interpretations for forestry. Forestry has become kind of interested in soil fertility as much as farming did, and there's been some use of fertilization and stuff like that. I know one of the soil features in the forests, like in Clearwater County and Latah County, there's a thing called a fragipan, which is it's a dense layer that prevents water drainage So it'll have that E horizon, that bleach zone on top of it, just like the sodic stuff does. But it's formed by a different process. Actually, we don't know what the process is. We just recognize the frangipane when we see it. But we're not really sure how they form exactly, because they've been investigated quite a bit, and they're not cemented by anything. So there's not like iron or silica or something sticking them together to make them so dense and impenetrable. It's just a packing arrangement of the grains. Somehow over time, things have gotten so packed together that water can't get through, except along cracks in structural units or something like that. So anyway, where this frangipane exists, there's a real tendency for disease problems in like grand fir. They'll get root rots and things like that, which makes sense, right? They're sitting in perched water a lot of the through the winter. Foresters became interested in that, right? To say, oh, well, these are the stands where we can expect disease problems because they've got this frangipane sitting underneath. The frangipanes are also kind of poor for septic systems, things like that. Houses with basements can be all right, but you have to have good drainage, right? Because you're digging a well in the frangipane, and the water's going to flow in there, so you got to have a good way for it to get out. It won't flow out through the subsoil. You've got to have something up near the top to drain it off. And that's an example of a feature that people like to know about. And we do interpretations for building homes with basements, engineering materials. The soil material itself, good as a source of sand or gravel, something like that. A lot of ours around here aren't, but you get up around Coeur d'Alene where they've got more of that coarser outwash deposits. You can have good sand and gravel up there. Even, something you could exploit and sell for that matter, rather than just use locally. And so I guess those are a few examples of the kind of things we try and report.
So obviously we care about conservation. That's kind of what we do at the Nez Perce County Soil and Water Conservation District. And now that we know so much about our soils, or that you're working to map soils or understand soil types, how can we help conserve our natural resources? Soil is a huge natural resource, obviously, and it doesn't come quickly, and we need to protect it. But how can we do that? And as a society, are there issues that we should be worried about that could be affecting our soils, or I guess for better or for worse, if you can think of any?
NRCS is, the descendant of the Soil Conservation Service, and the big thing was soil erosion, right? Which is still a big thing, right? The Palouse in particular, has a lot of steep slopes and a lot of easily moved material. That's silt loam material. It moves in water, it moves in wind. On the eastern Palouse here, I don't think wind erosion is quite such a big deal, but further west, it is. And we have the water erosion here on the eastern end to worry about. And practices like minimum tillage, right? Anything that protects the surface of the soil is going to be beneficial. As you're probably aware, in recent years, the agency and I think farmers in general have gotten interested in, I don't know what we're calling it these days. It was soil health, soil quality, some different things like that. But it's pretty exciting stuff, really. It's just the idea of thinking of the soil as an ecology, especially the carbon dynamics of the top foot or whatever. So you get into things like no-till and the use of cover crops to try and increase the amount of carbon cycling in there, which leads to better structure of the soil, right? You get more aggregates in the surface, which causes better water uptake by the soil. When it rains, the water goes in instead of flowing off. I think you can see improvements in disease and pest resistance in plants because they're just healthier. You've got an active, dynamic little ecology going there. And I think that you can see a reduction in the need for inputs like fertilizer and pesticide. At least people have shown that. Most of the work I think has been done in more humid eastern areas where you get your rainfall during the growing season. So how to apply it in our xeric environment where you've got, most of the actions in the spring and then things kind of dry out and the soil ecology is going to slow down, right? Because everything's so dry. So I know people are working on it. I'm not sure how you make the application to our area in particular. But it's exciting stuff. There's lots going on. People are really working on it. And I know some local farmers are trying to implement these kind of things. Curious how well they're doing, what they're finding out about it, because I can see the YouTube videos and stuff about the guys from North Dakota or wherever that are doing it. It'd be fun to see some local guys and see what they've been able to accomplish. I know I did meet a guy that farms over on the Snake River near Almota or someplace like that. And he raises corn, which I thought was impossible around here, right? Because corn takes a lot of water and it needs it in the hot weather, but he's figured out how to do it. And he must have good quality soil because he's getting the crop off all on stored water. So I should have talked to him a little more about just exactly what his system was. So there's things out there.
Right.
Yeah.
I mean, you always hear things like no-till or soil quality. People talk about that a lot in the conservation society, I guess. But I don't think we think about the fact that different areas have different conditions, and the same conservation methods might not work the same, on this side of the United States as it might on another side. I don't think people necessarily always think of those factors, like the specific soil type can totally affect how you need to be treating your land and whether it has that issue in particular, like water retention. That changes what you need to care about and how that really affects people. And if it's even an issue, if people can figure out the way to work with it, we believe it's important to work with our environment rather than against it. And so if people are figuring out those things, that's just amazing that people are able to, over time, kind of learn the little odd parts of our environment and our soil quality and figure out how to utilize it for good and what our environment makes available, and you got to work with what we got.
I guess I could mention that there's the online resources that we've got, so like Web Soil Survey, if people aren't familiar with that is our delivery method for soils information now. We don't do the published soil survey documents anymore. It's all through the online portal, and it's pretty easy to navigate. I think you get in there, you can set up an area of interest and then extract all the soil information, and all those interpretations are there. They're available. You can get the ones you're interested in for the tract you're looking at, and even make a little map showing it's good here, not so good there, things like that. There are some other, like soil taxonomy. If you're interested in that, you can get a hold of it. NRCS websites. The taxonomy document is available there. And if you want to get into the weeds, we've even got a site for the official series descriptions. I talked about how there's the soil concept, and you try and decide if the soil individual that you've dug into and are looking at fits this concept. The official series descriptions are that concept, and they show you the kind of the boundaries of the box. See, does this thing fit that or not? And so it's all the names and all the classifications, lists of kind of ranges of properties and stuff. So if you're enough of a nerd to want to get into that, you can do that. And there used to be a thing available. I'm not sure if it's still out there. That's guys in Davis, California came up with this. It was an app for the phone, right? That would tell you what soil you were standing on. Go to a place, and then it would link to the Web Soil Survey information, tell you, okay, you're in this map unit in this particular place, give you some information about the soil, get it in real time, that kind of thing. NRCS soils, I think if you Google around, you can find a few different things if people are interested in getting into it and researching. It's certainly public information. We're not trying to hide it.
Huge thank you to Brian Gardner for taking the time to meet with me and share his expertise. Our soil really is an incredible resource in need of protecting, and I hope you appreciate the soil that serves you. Happy World Soil Day.